All right. So hello, everybody, and welcome to the DataFinz webinar. And today on our agenda, we have our webinar that's going to run from 10 a.m. to 11 a.m. So it's just an hour of your time. This event will be recorded and shared for your reference, so you can always refer back to this recording later. And throughout the meeting, you can post your questions in the Zoom chat to get clarified on any questions you have. And there will be a Q&A session at the end. And we ask also that everybody is muted during the demo and unmuted for the Q&A session. That's going to be at the end. And our speakers today are Guru Rajendra. He is our product owner, and he is an experienced data analytics professional. He consulted analytics solutions for multiple Fortune 500 companies. He's done very extensive research in APIs and data integrations, and he's also done digital transformation roadmaps for CXO levels. Our other speaker today is Kavi Krishnan. He is our product architect. He is an experienced enterprise architect with very hands-on experience. He's done research in cloud agnostic connectors. He's an expert in SOAP and REST APIs, and he's also an optimal solution designer with automation skills. So any questions you have about APIs will be answered today, and any questions you have about DataFinz will also be answered today. So if there are no further questions, we can go ahead and get started.
Sure. Yeah, thank you, Sarah, for the introductions. Kavi, let me share my screen and we can get started.
Hey, thank you, Sarah, for the introductions. Hello, everyone. I'm Guru. I will be covering the demo today along with Kavi. First of all, thank you, everyone, for joining this session. I'm sure it will be very informative and useful for you. I will start with a quick introduction of DataFinz. Hey, we are data professionals and have done several engagements in data projects for multiple customers across the globe. What we have observed in those engagements were the common challenges in data integration across the customers. When we take a deeper look into such challenges, it is more of a technical in nature and not business-oriented thing. But still, customers are spending significant amount of time and their valuable resources to handle or resolving such integrations part. So we took that as a problem statement and built this no-code integration product called DataFinz to free up your valuable resources. So our motto or mission is to simplify the data integration services. So what we have done is identified some of the common patterns and created them as engines, which can be configured as pipelines to handle variety of use cases. So we have created 6 different pipeline engines. Today we will cover 2 of them related to API ones. And this product is very highly secured, and it is available in cloud and on premises as well. And the tool is very easy to use, meaning you don't need to learn one more technology to become proficient to use DataFinz. So let me get into APIs. I know most of you are familiar with what APIs are, so I'm not going to cover in detail about that. But API is trending in these days because of its simplicity and accommodating variety of use cases there. And still the software programs can independently communicate each other from the client as well as from the server. It can be 2 different platforms or OS, doesn't matter. The APIs are designed to perform a certain business activity. And the APIs are exposed in 3 different protocols, SOAP, REST, and RPC. And again, it uses XML or JSON as predominant formats. Out of these, REST is getting popular these days because of its lightweight usage and caching options available. And if you see, there are 2 sides of API. One, providers who are creating and exposes the API for their different business use cases, right? So it could be they can share the APIs to internal business teams or to the public or to the partner to share some of the information. And the other hand, consumers are the ones who write some software programs which can talk to these APIs, get the necessary information, and provide meaningful insights or meaningful information to their end customers. So they can create the web application or mobile applications to handle, to show the data, or sometimes they use for data enrichment. In case if you need to standardize your addresses, you can get it from Address Doctor and standardize in a native US format through the API calls and store it in your MDM system. Or we can very well use for analytics in case if I want to measure the performance of the flight, I need to get the data for the past 2 years and store it in the structured data. So which means I need to parse the information from the APIs and get what all the timings it is meeting. And eventually I use that to run my analytics and create the prediction model algorithm to say what would be the likelihood of meeting the timelines in future for those flights. So both the sites, both providers and consumers, they write programs or maintain modules to handle these kind of functionality. We'll take a deeper look on each one of them, what they do. So let's start with the consumers. API consumers, they write a program to send a request to API, receive the response, parse it, and handle for their needs, right? For example, if I want to use get query, right? I want to find what are the flights between Dallas and New York from the United Airlines. So I'm going to send a request. So I can type in those in UI forms and hit search button. So once the search is clicked, these background UI routines, it will try to parse it to a JSON or XML, or it reads some structures from the database. It's going to adhere to the specification, what was written in the API, and figure it out whether all the needs, whatever the mandatory fields are given in that particular request, and it adds the header and security on top of it. So in case if there is a push or other methods, it's going to add body to it, and it will send that request to the API endpoint. And once the API endpoint reads it, it is a black box for consumers. We don't know what happens, and it's going to spit the data output, right? So that our data output, it could be just one record, or it could be several thousand records. So whenever there are several thousand records, it's not going to send that complete data set because of the performance and other constraints. They are going to limit the number of data sent in the output as a response. They are going to get maybe 10 objects or 25 objects at a time. So this is where they do the pagination, and our response should be aware of how many records I read it, and I need to read the next set of records depending upon the needs, right? So I read the response output, handle paginations, and sometimes I do the parsing of that response for the analytical needs, or I directly use that output in UI itself. So this is a classic case for get methods. But these days, even all the customers or all the providers, they offer options for the consumers to manipulate the data in the provider's database, right? So for that, the methods are push, put, patch, and delete. And here the structures operations could be slightly different, meaning it will have same request and response, but in the request will be little tricky when compared to the response. So we are going to add the body now. So in case if I have my structured data, I need to share some of to synchronize my in-house systems to the enterprise. I'm going to convert all my structured data and convert into semi-structured as per the specification given and include it in the body and push that data. Once that is done, the output response is going to be a very simple one. It will say the data is updated or loaded successfully. So that is the complexity between the push put classes when compared to the get class, right? Now let's see how DataFinz is going to help with these kind of requests in few clicks, how I can handle the get classes as well as for the push classes quickly. So let's take the first consumer use case. So the consumer has bought a new enterprise product called Uplift. So it's a CRM product. Earlier, they maintained their own legacy application to maintain all their customers' opportunities, etc. Now, that legacy application, the data is maintained in the Postgres. They need to migrate all the data, and most of the things are done. But there are few customers which are added of late. We need to add them back to Uplift. Good thing is all the enterprise customers these days, like Uplift, they expose an API to migrate the complete accounts from your legacy, right? So we are going to make use of that API and see how DataFinz will help in that particular case. Let me let's go through the JSON structure, the specification, what Uplift has created. So it has some account information, and for that account, we have the contact details, and underneath contact, then we have opportunities, then we have codes, code details, orders. So it has n number of things bind together and sent in a denormalized format. So now let's take a look how we are going to make use of DataFinz for this. So this is a login page for DataFinz. Okay, so it will end up in first page is going to be the dashboard page, where it gives more information about my inventory maintained in DataFinz. So this covers all the connections, various connections, what I have. And then it talk about pipeline, the 6 out of those 6 pipelines, how many are number of workflows I have in each one of those pipelines. And then the API publisher, in case if I expose any API endpoints through DataFinz, what are the different methods I'm using it, and how many are active and how many inactive. And for the pipeline runs, how many have I executed so far along with the success and the failed ones. And over the top, we have a ribbon. So in this ribbon, we will have all the pipelines, whichever is for easy operational needs, we have added it in the ribbon. And then we have a frequently used one, job history, to check the complete historical view of how the jobs performed. We have admin to take care of the access rights and the modules related to license and other things, etc. Okay, so then we have a configuration page. Let's go to configuration. So here we have different options to configure the connections, some data type related to for other application modules, data type is useful. And we have a scheduler, and for the deployment across the environment, we have a modules related to that. So now the main thing is connections. This is one of the unique value add we are offering because we spent a tremendous amount of energy in connection modules to structure out dynamically the different connections, whatever available, right? We have a variety of technologies and all those things, how we can handle it through single module of connections. And when I go to connections here, let me create new connections. So I have all most frequently or most common ones, everything is available, like FTP, SFTP, FTPS, etc. And the parameters here is they're going to dynamically change based on the connection type what I pick. And I have an option, we created a hint. If I click hint, it will give information about what I need to add in each one of those. So this will be very handy. And like our other vendors, they will be charging heavily on the connectors part. So we are, depending on the services what you take, we offer variety of connectors at economical cost here. So now for our case, I have to interact, or I have to integrate Uplift API with my Postgres application. So which means I need to create two different connectors, one for Uplift REST API and the second one for Postgres connection. So let me go to the REST connection first. Okay. Oh, sorry. Okay, I have Uplift accounts. So this is the API exposed by Uplift to migrate the accounts. So I named it as Uplift accounts, and it is REST 2.0 JWT connector. So for that, I need a callback URL, which is going to create my bearer token. So this will automatically, during the access, it will automatically connect and generate the bearer, and it will add it in while sending the request to an API. And this is the host address, and the endpoint is bulk, and bearer token is access token here. And we have other options for variable file connections in case if I need to dynamically change different parameters in the host, I can make use of that. So now once all this is done, I can test the connections, and it's done. So the first connection is done, and the second one, I have to add it as a Postgres. So let me pick the Postgres connection here. So Postgres, this is a straightforward one, like any other JDBC connectors. So I picked the connection type as PostgreSQL, and I give the URI for the JDBC connector with the Postgres and database name, login, and password. And we have switch schema in case if I want to switch to a different schema, I can change it here and test it. So this is done. So the two connections are done. So the first part is over for me. Now let's move on to the second one, which is a model. For APIs, whenever deal with API-related pipelines, we suggested a new option to understand the structure of the APIs. So for that, we introduced the model. So the model is nothing but it will take your Swagger specification or any of your JSON or XML template, and it will generate, it will make the system to understand how the metadata is going to come for this, right? So that is the primary step of this model. Let me go on to API pipeline. And I have a model. So I created a model Uplift accounts here. So I name the model name and name it as a post request, this one. I have three options to model it. I can give the JSON by uploading it, the file directly, or I can provide the model body. So I copied the entire JSON, which I showed you earlier. I copy and paste it here. Or other option is I can directly connect to that REST API and get that JSON or the Swagger spec directly from the API itself. So once this is provided, I hit the generate button, which will parse this entire structure, and it will create the ERD diagram. So let me download and show how the structure is going to be. So it will create ERD diagram along with the SQL statements and the templates for the CSV files and templates in case if you want to make use of CSV part, right? Now let's take a look of ERD diagram. So here it is structured in a normalized format. Like we have accounts at the top layer, and underneath accounts, I have several contacts. And from accounts, again, it is connecting to the opportunities, all the opportunities for the accounts. So this is one array, and this is another array. And then within the opportunities, I have another array, which talks about the codes. And within the codes, there are two different arrays. One is order, and another one is code details. And within order, I have order details. So if you see, it is a recursive array set defined in this particular API. Now I have to go through my legacy Postgres system, and I need to map how I can map all my accounts here and the related opportunities to this, and all the contacts related to accounts to here, the codes, orders, etc. So this will be very handy and helpful for application teams or data teams. Instead of fighting with the JSON or XML structure to understand the metadata, I can just go through this single page and understand the entire structure more quickly, right? And any of the other vendors, they are not giving anything related to this entity relationship diagrams for APIs or JSON or XML. So this is so unique, which is offered through the DataFinz. Now the first part of the second part is also done. I created the model. It's done. Now the third part is I had to create the pipeline linking my Postgres to this REST API. So for that, I had to go to integrate. Okay, so now I created a new pipeline called uplift migrate accounts. Okay, so before going here, let me quickly show the uplift application. So this is the uplift application where I show the list of customers here. So if you see, the last customer added is Boeing, and we don't have any other customers. Now I'm going to add 5 more customers through this process. Okay, now I have integrate. I'm going to edit this one to see how the structures are going to be. Okay, so the first step is configuring my source and target, right? And I have to bind with what the model name is, especially for APIs. I have to tell what is the metadata structure going to be. So I'm going to use model name as uplift accounts, which we created now. The source connection is Postgres, target is uplift. Target is uplift accounts, which is the REST API. So if this is REST API, I don't need to give the target file name. But in case if I don't need to connect directly to the REST API, I'm going to put it in S3 or somewhere. Then I can generate the file name directly here. I can give the file name what it should be. And here, if you see target process split rows, I'm giving S1, so which means the system automatically, it sends the request with one object at a time, right? Because there are limitations how the provider has defined this particular API to be performed. If it's going to accept 100 different objects, then I can put it as 100. So the way DataFinz, it is intelligent enough to determine send the API request for every 100 objects. And if there are more than 100, it's going to send the subsequent request as a separate call instead of everything dumping together, right? So if I give 0, it's going to send everything together. But depending on the restrictions, I can make use of this split rows. Then next, I have the objects. Now, if you see all these default object names, it's going to come from that model, what we generated. And we also structured this in an indented way to make sure this is a parent and this is the child belonging to it. So that it's kind of very informational so that we don't get confused. And now I'm mapping to my legacy application. So this is the legacy database. And we will give all the object names here directly based on the source connection. So since I use Postgres connection, I'm going to show all the tables available in Postgres. So it is easy for me to pick which table it belongs to. And I have an option if I need to filter anything, I can do that filter as well. So now I mapped everything here, equivalent objects. If I don't give object names, it will expect in Postgres the same table name there. And here, instead of table name, I can make use of views also. And this will be very helpful for post requests in case if the structure in legacy is not in line with the API, I can write a semantic view which can map to this particular structure. So that's the step 2. And step 3 is more at a field level. So whatever objects tables I picked, it's going to appear on the left. And now I can map how the target field names are going to be here, right? So if you see, everything is the same, except the key fields in the legacy, it is different. We are going to map it like that. And we have a masking option in case if we want to encrypt anything before sending to the APIs, I can do that. Or if I need to add any small transformations, I can do that too. And if there is any new fields which need to be dynamically added with a simple logic, I can do that too. So once that fields mapping is done, I can go to step 4. And here, one point, if I don't give any field names, it will automatically expect the same name. And this is again the optional part. So everywhere we have designed such that all these are dynamically going to be pulled. You can edit it in case if you need to overwrite anything. If it is going to be default the same, then you don't need to do anything. It's just do click, 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 and done, right? And the last part is ELT scripts. So this is far more for developers in case if I need to do any pre-processing options by running any scripts. I can make use of that. If I pick pre-processing and tell what is the database connection and what are the procedures I need to execute script name, I can do that, pre or post. And it is more of an optional part. So here we don't need it. So once this is done, my integration part is completed. Now it is ready. I'm going to run this process. So I'm refreshing it. So this is the job history. It gives when each particular run happened. Okay, now this particular process is complete. We have 5 new different customers, and it is transformed into structures. Total size is 12 MB. Now let's take a look into Uplift. I'm going to refresh this page. Boom. If you see now, we got 5 new customers from Staples, Walmart, Best Buy, Office Max, Target, etc. So now I can go to any one of the customer, right? So I get all the information related to that Staples, then the contacts, and the opportunities, different one. And within the opportunity, I have quote details, right? And the existing functionality, I can generate PDF and XLS those. These are product features. And this is only one quote available. Again, I'm moving back to companies, Staples. I can go to orders. So same order is going to give that information about what all the different things, delivery date, etc. Total related information. So if you see all these 5 customers, even though we are saying 5 customers, but it is completely migrating the package for that particular customer. Who are all the contacts? What are all the opportunities within that particular account? And all the orders related to it. So everything is mapped and sent in a single request, and it is this particular thing, DataFinz, it push the accounts one by one, and it completed for all the 5 accounts. So now we can see how easily I'm able to integrate to any enterprise products, even the same case with a Salesforce or Workday. They have that set of APIs, so we can directly integrate with my in-house system and handle it. Let's go to second use case. So this is a inventory analytics. So now I have Uplift CRM as my transactional system, and it maintains the inventory data along with the CRM. So from EDW, we maintain all this data where we need to synchronize on daily basis what all the different things happening in the transactional system. And I run my analytics algorithms and create the inventory analytics for that. So for product related thing, I want to know for this particular product, how many are in order and how many I have so far, so that the supply demand is taken care. So for that, there are set of dashboards available, but I need to integrate from my transactional system Uplift on a daily basis. So which is going to be in API, but my output results are in a structured format in EDW. So let's see how I'm going to make use of that API and convert into a structured data and finally expose it in the Power BI reports. So again, the same steps. We have the connect. So here, two different connectors again. My EDW is in Snowflake Cloud, so I have to configure Snowflake. And second, I have a Uplift REST API. Again, this is a different endpoint. I'm going to make use of that. And the next steps are same thing. I have to model it to understand the JSON metadata. And finally, I will do the integrate. So before getting into it, let's see the Power BI report. So this is the Power BI report. The product name is MacBook Air. I have 7 pieces available, but in my open orders, there are around 14, and I have out of stock of 8. Okay, so this gives an alert to the inventory maintenance people so that they can make us orders from their dealers and fill their inventory, right? So this is a day -2 report. Let's see what happened, whether they have taken any action to fill this, to manage this particular order. And here, this is a nice chart showing what is my credit and how much am I selling here on month-on-month basis. And here it shows the favorite customers who are ordering this particular product. Okay, now let's get into the integration part. Okay, so first step is I have to model it. Let's go to model. We have a Snowflake account. See the Snowflake. Again, Snowflake is another JDBC connector, so it is going to be a direct one. And here, Snowflake JDBC connector, we have to share the information on the warehouse, schema, database, etc. Right? And if I need to know what all the things I need to pass, we give a hint there and talks about database, schema, warehouse, etc. So this is done. I created the Snowflake account. Then I had to create the REST API. So this is Uplift product. So I'm going to get the product information, again, JWT, so which means I need to pass the callback URL. So where this gives the information on the bearer token after uses this to log in and generate the bearer token, and that will be passed as an access token during the call. And this is the host, and the endpoint, if you see, is the product analysis endpoint. And they have defined this host to accept one product ID at a time. So this is where we are bringing in the dynamic parameters. So for this dynamic parameter, we maintain the Azure variable connection, Azure blob. So in the Azure blob, we have the CSV sheet, which talks about what are all the product IDs I need to run through the process. So in case for any dynamic thing, I can supply a flat file here, which will map each request. It will route it with one product ID at a time, and then it will read the next product ID and it will run through. Or I can write a SQL also here to show what all the product IDs I need to run for it. So that's about the connections. I'm done with the connection. So then let's go to step 2 of model. So here we already created the product API. Let's take a look. Again, we have to supply the JSON. I can upload it or directly paste it or directly configure to a REST API. So here it looks different format. So once save and generate, it will parse the structures and completely generate the ERD diagram along with the table views, etc. Let's take a look here. So this is the structure of the API. So I have product information. So from product, I have related opportunities. How many opportunities are using this product? And within that opportunity, they have codes and codes, how much quantity it has. And same product, again, they have the order. This has the order related information along with the customer names, delivery date, etc., the order quantity. And it also has stock history, how much it was utilized so far. Now let's think about the report, what our dashboard, what we have seen. It has the elements from here. It has the stock history, which is populated here. It's coming from here in the stock history. And for the favorite customer, again, it comes from the order details. And we have that customer information along with the order quantity, how many they are ordering, that gives the width of the favorite customers. And I have the stock history again mapped to on hand to talk about how much it is coming through. And I have the order information to determine how many are still in open order based on the delivery date. So this entire dashboard is coming from the output of here. But if you closely watch, I don't need opportunities, codes, or code quantity, right? So with the API, I can quickly define, understand the structure. I can create algorithms, or I can write the DataFinz workflows to copy these structures alone to my EDW and create the report, right? Now let me go back. So now we completed the model. Then the last part is integration. So I have Uplift products available here. So same kind of layout, what we have seen earlier. So here the pipeline name and what is the model name. This method is get. Last time we have seen post, where pushing the adding data to an API, now receiving data from an API. And source connection is REST API, target is Snowflake. And I have an option here whether I need to run it truncate and delete, which means full, or I can do it in incremental, which handles update or insert mode. So step 1 is done. Now step 2, the same step, I'm going to map each one of the object generated in ERD to map it in Snowflake. So I can give the table names, equivalent table names, or if I do not give anything, it will create with the same table name in the target. If I need to filter anything from the API, I can do the filtration logic here. And the last one is at a field level. So in case if I want to change field level names, I can edit here. We have masking option for any encryption and any transformation we need to add, we can do that. And the last step is pre or post process. If we need to create any data lakes by having some other SQLs or stored proc, if we need to execute it, I can make use of pre-processing step here and pass the information, right? So that's it, I'm done. Once this is completed, then our pipeline for the product is ready, right? So now I linked the entire thing, the REST API to a Snowflake, right? Okay, So now let's go ahead and run this process. Oops. All right, so now the process is completed. So we have the product data coming from API to Snowflake. So now I need to refresh my reports as well. So this is the report, which is already available. We have seen. Let me go ahead and refresh my reports with this particular data. Okay, the reports are refreshed. So let me go ahead and see the output here. Okay, so if you see, last time we did not have the credits for June month. So now they have added around 14 quantity. Someone from the inventory team has taken the action based on the alerts given. So now they added it, and there are still 14 open orders. And we are good to go. So there is no out of stock. So here it shows 0. So now you can very well think how this synchronization is done on daily basis with the API. I don't need to write any code, and automatically using DataFinz, I'm able to parse the structures and feed the data to EDW or to the analytics environment. So if I need to schedule all these processes, I can do through API DataFinz itself. So I had to go to the configuration, get the scheduler. So we use cron scheduler. So you can create your own schedule, run once or recurring part. I can create the build schedule where we give nice information about whether it needs to run on daily basis or whatever time. So if I pick, it will be informational here at the down what options I pick. So now I pick 2 hours, so which means it shows at 2 a.m. Monday through Friday. So I can save this information that will give the cron expression how I need to run the job. So then in the next step, I can say I have to give the schedule name. Okay, so now I can pick the objects. So this is the API pipeline integration part. I can pick that. I can click get accounts and save it. So I can pick in case if I need to add a next job underneath, I can add all group of jobs to execute in sequential way. And finally, the email step where if I need to give a notification, we have a good option whether do I need to send notification for success or failure or for both. I can send the list of email addresses and I can add and schedule it. So if we see the entire package all the way from the mapping, understanding the structures to connecting to the warehouse or analytics, the end-to-end in simple way, I can do it. So that's more of a API pipeline, which is helping the consumers in integrating different APIs here with security scheduler with different connectors. I can bring it to any relational or unstructured formats and powered by dashboards, job history, run statistics. And the features, just to recap, we have an entity relationship diagram for API data, and we can automatically create payload requests for structured data, and we can parse the complex structures, nested array structures, everything quickly. And variety of connectors are available as well. Benefits, it improves the productivity like anything. And we have done the comparison with the manual creation of this integration part and through DataFinz. So it gives 99% productivity improvement. And from the cost savings, it gives 81%. So this is due to the addition of other PLM project lifecycle methodologies like project management, tester, etc. So all those factors will be there. So due to which it comes to 81%. Now let's look into API providers. So API providers are the ones who is responsible to create the API with some business logical, with some business logic, right? The exposing an API, again, they have to maintain set of modules and routines. It's not that easy to create an API, right? I have to look for the security so that someone don't hamper my system, right? And I need to figure out what kind of business logic I need to use, what methods should I give, get, post, put, patch, delete, I have to handle pagination, I have to write the documentation for that particular API, and I need to track and control the usage of those APIs, who is using it. And eventually for API providers, they need to monetize the usage of such APIs. And then they have to link it to the databases or flat files or sometimes to any operations, what they need to do. And the other part they have is Swagger or Open API documentation, which can bind all your endpoints to an application, and it can be exposed to any teams so that they can do a quick data checks. So that helps in this agile world to validate the data quickly, and they can start their own programming other parts. Right now, let's see how DataFinz is going to help for the API providers. Okay, so the first use case, we want to expose the analytics platform as an API. So we have data analytics team. So they have the entire EDW, big data, data lake, etc. Everything is there. And finally, they run the predictive models and generate their output in data marts, and they expose in reports or dashboards. In addition to that, for their internal thing, they want to expose this data to other internal teams and external partner teams, right? So the one simple way is API. So how easily the data team can expose their data as an API without writing a code. Let's see how DataFinz is going to help it. So here again, 3 steps. So first step is connect, which is same like the earlier one. And again, here only one connection, right? Because it's always the source connection. And the second part is I had to set what kind of authentication it would be. That would be set at the application level. And then we have to design what are the different objects. I have to pick the objects, pick the attributes, methods, etc. And finally, I publish it. Now let's take a look how this model look like. So for this, I'm going to get into API Publisher. So in the designer, we see the list of APIs published. Let's take a look into sales. The sales is coming from the Snowflake connection. So if you see, we have created APIs from Azure Data Lake, S3, Azure SQL, Oracle, Postgres, you name it, we can create APIs from anywhere, as well as from any type of database object like table, view, stored proc, or flat files, etc. Right? Let's look into the sales API. So this form looks like at the top what is the API name going to be, object, and what is the object name. So here we have used Snowflake, and I'm picking as an object. When we pick as object, all the objects going to appear here. I can pick that, or I can do a custom SQL or object. Even the views also I can pick. Or if I pick stored proc, all the stored procs is going to appear, and I can pick from there. And these are all the current endpoints for this particular object. So we have write endpoint with post call, and we have read endpoint. I can create a new endpoint as well. So let me show how the existing read API was created. So this is the get call. So step 1, we finished picking the object. Step 2 is the endpoint, and we are naming it as a read. I can give the endpoint description here for the documentation purpose. And what is the option? This is get. Once this is done, I'm going to pick the attributes. So I'm picking 3 different attributes: order number, quantity ordered, and price each. So good thing here is it's going to come up with a camel case suggested field name. It will automatically come with the camel case. And if I need to overwrite it, I can go ahead and do that. So that's for the selection of fields. And the last one is filter. So filter is something in case if I need to ask mandatory certain fields for the get calls, I can enable that. So this will be a mandatory field for a consumer to pass that information. So here I'm going to get the order number and finish it. So once this is done, so this API is active. So I can reach a test validate it using Postman or any other thing. And for the security related authentication, it is set at the application level, right? And I can start or stop this API. So we have the sales here. So if I stop, it's going to stop that particular service. And I can schedule this in the scheduler so that for a certain period of time, I can make this API as an active, and rest of the time I can stop it in case if I need to focus on my infrastructure savings, I can make use of that. Okay, so now let's take a look into documentation part. So that's the creation of APIs. So you have seen how quickly I can expose my any database object or flat files, which can be anywhere, into an API. So now let's look into the last one, which is a Swagger or Open API specifications. So now I have a list of applications or list of endpoints. I can create a Swagger documentation. We don't have any other vendor providing the creation of Swagger automatically from the APIs. So this is one of our unique value add, where API endpoints created through DataFinz, we create a Swagger quickly, and it's just few seconds. I don't need to do anything. Just add the endpoints and publish it, and that will be operational for anyone to use. So again, 3 steps here. So I create an application. I'm going to set the authentication methods. So this authentication method, it will run for the entire endpoints. If I set the authentication method as JWT, it's going to, for that API endpoint, you have to use JWT authentication. And then second step, add the endpoints and finally generate the Swagger. So now let's take a look how it is done. Within the API publisher, come to the documentation. So in this documentation, we can see all the APIs available, all the Swaggers available. So for convenience purpose, we have created 3 different Swagger documentation. One without authorization, one with bearer token, and last one with the basic authorization. So the moment, let's edit one of the Swagger and see, right? So we have first step, we have given what is the application name, and I have set the authorization type, basic authorization. I can add n number of users to it so that I can track who is using this particular API, right? And second step is the module. I can create the modules. So here for convenient purposes, we created few modules and we have given what is the source for each one of the modules, right? It's like for accounts, we are creating from S3, from the CSV. Customer, it is an Azure SQL, sales Postgres, Snowflake, RDS, and Azure Data Lake. So these are some of the modules we created. And step 3 is whitelisting. So if I need to whitelist some of the IPs, I can give the ranges here. So only those IPs alone will authenticate, or our gateway will allow to enter. Otherwise, it's going to block it there. And finally, the endpoint selections. So here I can pick whatever endpoints bind to this particular Swagger documentation. I can build it. so that I can create specific Swagger documentation for my unique set of business teams, and I can publish it. So once this is done, it's done, and I hit the play button to generate the Swagger. So the Swagger is created. We can go and click this to view the Swagger. So this is the URL, which is unique for this particular application, where you can expose this to any of your external customers and give the basic authorization, since we have set it as basic authorization, for them to validate. So if I go here, I can take a look. Okay, so this is the gateway, and I have the modules, whichever I created, it's nicely fitting in the proper format. And what are the endpoints tying to each one of the module, like account, I have get, customer, I have patch and get, etc. Everything, right? Now I can authorize, if I'm an external team, I can authorize and I can validate this data quickly. So this is ETF flow 1. I'm going to put hit authorize, so it is done. So I can quickly validate how my sales read is. I'm going to make use of this one. Can do try it out. And the order number, I'm going to send it as 1. Since I have made that as mandatory, I have to give that. So if you see the response is 200, I'm getting the order. There are only 1 records. And the order number, what is this? So we automatically give what are the total records and how many are fetched in this particular case. And second set, we will give the data as an array. And finally, we give the return message status and return value, etc. Right? So now, simply, I'm able to expose without any coding. I did not do anything at all to generate this Swagger page. So it is very quick. Now, if I go and let's say I'm going to stop this sales service. So I stopped it, right? So I have an indicator here. It shows the status is red, which means it is not active. And this valid status, it shows everything, the specification, the connections, everything is valid one, but this is not active. Right? Let's see what happens if I'm going to run the same thing again. So if I hit, now I'm getting a message saying API is not active, contact admin. So it's a good scenario for us to validate if you want to make it active or inactive. You can do at any point of time without doing any implementation. But if you look into the other vendors or other architectural streams, you have to explicitly deploy if I want to stop any one of the servers. So all these things are automated now. And it's a click of button. You can do start your service and stop your service. So that's, if I need to activate again, let me activate it. It's done. So let's rerun and see how it comes through. Go to execute it. It's done. I'm getting the data now. So that's on the Swagger part. So how easily we can create and expose to the data teams, right? So nutshell for the publish APIs. As an API provider, DataFinz is going to expose all your source systems as an API endpoint, and we also create the Swagger for that. We have features like start API service, stop API service, and monitor usage. And let me show the monitoring the usage part too. So we have here usage. So this will show all the queries which are hitting here. So right now we have checked on the ETW1 sales read. So that is coming here. I can view the complete information on that and what time it was hit and how much it took. All those information are recorded. So that's the monitor usage. And eventually we are planning to have the mechanism to allow the access only for our users during a certain period of time. And we can also measure how much queries they can, or how much APIs they can hit, right? And accordingly, we can set the licensing and other thing depending on the provider's terms to their end users. Those things are in the beta version. We will be launching it soon. And here are the API consumers where they request and they get the responses. So we have seen how we can create the REST APIs in clicks, and it can expose tables, views, stored procs, flat files, auto generation of swaggers, track and control the usage of APIs, and authentications in the application. We have seen basic. We have JWT or NoAuth also. So the benefits here, again, 99% development productivity, and cost savings are much more higher because the process here is slightly different. So that concludes the presentation, and we open up for any questions. Thank you.